In order to learn the steps how to get the Laplace transformation and inverse Laplace transformation, let's start with the most basic, the simplest form of a function. And the simplest form of a function is when that function is equal to a constant. So let's assume that our function f of t is equal to a constant, is equal to a. So we're going to show the step to get the Laplace transformation of that, and then the inverse Laplace transformation, and get back into our original function. So Laplace transformation of a function, we know that Laplace transformation of f of t is equal to the integration from 0 to infinity of e to power minus s of t f of t dt. And the result will be a new function which they show it with the capital F and the new variable s. So this will be integration 0 to infinity of e to power minus s of t, or f of t is constant, a dt. So since a is a constant, can come out of the integral, we can write this as a integration from 0 to infinity of e to power minus s of t dt. And the integration of e to power minus s of t is 1 over minus s e to power minus s of t from 0 to infinity. So this will be equal to minus a divided by s multiplied by e to power infinity minus e to power 0. We know that e to power infinity is equal to 0, and e to power 0 is equal to 1. So this will be equal to minus a divided by s divided and multiplied by 0 minus 1. So minus a divided by s multiplied by 0 is 0, and minus a divided by s multiplied by minus 1 will be a divided by s. So the Laplace transformation of f of t of a will be f of s equal to a divided by s. So this is the step for Laplace transformation. Now, for inverse Laplace transformation, the first step was we have to find the poles of f of s. And in order to find the poles of f of s, we have to set the denominator equal to 0. So to find the poles of f of s, we set the denominator equal to 0. So s is equal to 0. So our pole will be 0. Now the second step is to find the constant, the coefficient associated with each pole. So once, and that constant can be found in this relationship. We said that f of s in general will be in the form of that constant associated with our pole, that constant associated with our pole divided by s minus p. So our constant associated with our pole is equal to the limit as s approaches to our pole of s minus p multiplied by f of s. So our constant now associated with our pole 0 is equal to s minus 0 multiplied by f of s, which f of s is a divided by s. So here S and S will cancel out. So our constant associated with our pole 0 is equal to A. So once we find that constant associated with our pole, then our original function will be equal to that constant multiplied by e to power our pole t. So here our constant is A and our pole is 0. So our f of t will be equal to A e to power 0t. So e to power 0 we know is equal to 1. So our function will be equal to A. This is the simplest form of a function when a function is equal to a constant. So if we assume that this is our function f of t and this is our variable t, on the amplitude of A, our chart will be, our graph will be a straight line. So this is the simplest form of a function, but it is very important just to learn the step how to get the Laplace transformation and inverse Laplace transformation. I see you all in the next video.